Okay, welcome to random questions my students asked me about decision. Okay, first up, we've got a student here. Okay, so binary search. So we've got to use binary search algorithm to try to locate the word parallelogram. Okay, in the following alphabetical list. So step one, we need to know that this is in alphabetical order. Okay, so let's check it's in alphabetical order. So it does say alphabetical list. Arc, centre, chord, circle, circumference, diameter, radius. It looks in alphabetical order, doesn't it? Okay, so step one, what do we do? Yeah, so we're going to use the formula n+1 divided by 2. So how many are there in the list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 1, divide that by 2. What do we get? 5.5. And then we round up to 6. Okay? So we go to the sixth one. 1, 2, 3, 4, 5, 6. Its diameter. Okay, so this is the sixth one, diameter. We all know P comes after D in the alphabet, so we reject 1, 2, 6. Okay, so all of this has now been rejected. So now we know in the list, this is the seventh one. Okay, so we're going to start at 7 plus 10 and divide that by 2. And we're going to get 8.5. We're going to round that up to 9. So the ninth one in the list is segment. You can do this if you've labelled them. You could also, if you wanted to, mathematically, you know you have 4 numbers left. So you could do the amount of numbers left is 4 plus 1 divided by 2, which is 2.5, which rounds to the third one. So you could look for the third one in the remaining list. It will give you the same answer. Either way is completely correct, as long as you then state your working out. So we now know that P comes before F, so we reject everything after. Okay, so we're going to reject 9 to 10. Okay, so now we're left with position either 7 and 8, which we could do 7 plus 8 divided by 2, which is going to be 7.5. We'll round up, we're going to number 8. We have sector is the next one. Okay, or again, you could have done 1 plus 2, and then, you know, you'd be left with this one. Now then, from there, we look at sector. We know P has to be before S, so we're now going to reject number 8. Okay, now we have one left.
No, you just have to say, like...
Now, the position that's left is number 7, which is labelled radius. First of all, it doesn't begin with a P, and also it's not parallelogram, okay? So not parallelogram. So therefore, parallelogram not in the list. Now, just to say, in the mark scheme, even though I've seen this before, I'd highly recommend that that you use the place of the numbers. Just makes it a lot easier and it's coherent. Okay? Right, so drawing critical path analysis from a precedence table. Sometimes this can be quite difficult. Okay? What we just have to know is that there's a few things we have to take note of. Always draw in pencil and do not be afraid to rub out. You will get this wrong first time. Okay? So will I. And it's okay. So first of all, whenever we're looking, we have to look at a few things. So when we're drawing this, we see what is not dependent on anything. But straight away, we know that's A, B, and C. So we have our starting node. Now, don't worry about even writing numbers in here. That's just confusing everyone. Just colour it in. Okay? Now, from this, if A, B, and C are not dependent on anything, straight away, we know we're going to have A, B, and C. So that's easy, okay? And then, hopefully from here, we're going somewhere else. So we can do that. Everyone should be happy with that. I think you get 1 mark for this, but don't quote me. Right, now we're going to go down the list, okay, and we're going to do this one step at a time. So now, something that comes from A. So we know it's going to come from A. Okay, so that means A has to go into a node, and then we draw something coming out of it. So what has to come from A? D. Perfect. So we're going to have D. Okay, I'm just going to draw this. Okay, we always start like this, and that's okay to start like this. Next is E. E has to come from C. Perfect. Okay, now it's worth 5 marks. You probably get another mark here, but I have no idea. It's a funky E. Now we have a look at F, and we see that F has to come from A, B, and C. The only way that can happen is if we put dummies in, okay? F has to come out of something, but going into that node, okay, and I can see from here, B is probably the easiest. If you ever have if F is dependent on a few things, always look for the middle one. It'd be easier to draw. So F has to come out of here, out of B, but it also depends on A and C. So that means that node has to have 2 dummies, because we can't add any more time, but we physically can't draw A and C. Okay, so we have our 2 dummies there, because F has to be dependent on this. So this means the node before F has to have 3 things going into it, A, B, and C, but I physically can't draw A, bend it round like this. Doesn't work like that. That's why dummies are introduced. You'll definitely get a mark here. G also has to come out of this. Okay, so that's nice and easy. So what we can now do is G has to come out of this. I can just do that there. Okay, right, G. Okay, more happy so far. It might not look like this in a minute, but as long as we understand what's happening right now. Next we have H. So let's get another colour. So H is dependent on D, F, G. So D, F, and G. Okay, so I've got D, F, G here, and H is dependent on those 3. So remember, if something's dependent on 3, what did I say might be best to do? Put it in the middle. Okay, this is G. So that means there needs to be a dummy from D, because it's coming out, and there needs to be, sorry guys, that's H, isn't it? And there needs to be a dummy from G. Yeah? Perfect. Right, I is also dependent on A, B, and C, okay? Wow. So what I'm going to do now to make my life easier is, because I want to put it here, but it's going to look a bit messy. So what I'm going to do is I'm going to rub out E, okay? And just draw E down here now to make room. And then my I is going to come out. There we go. It has to come out of there. It has to. So far, everything I've drawn is correct. Might not look quite pretty yet, but it is correct. Okay, J is having to come out of DFG. DFG, okay, so here we go. There we go, J. That comes out of that node, and all 3 of them come out. Brilliant. K comes out of H. That's really easy, isn't it? So from H, what do we have? K. Okay. And then L, wow. So L, on the other hand, D, E. So let's just highlight what L needs to come out. L, essentially, needs to come from 1 point. And inside that point, it needs to have come from D, E, F, G, and I, doesn't it?
Just draw lines towards.
Okay. So, a few of you are probably thinking, okay, fantastic. I know what we can do. We'll just do this here, and then L can come out of here. Yeah? Problem is, we cannot draw a line. Okay, we cannot draw an arc if it does not have a letter to it. So this is where we now have to be a bit clever. Okay, get rid of that because that's completely wrong. Okay? So we know if K then, if nothing is dependent on K, this will have to be the last node as well. Yeah? So, where are we going? L needs all of these. So how could we do this? So if L depends on F and G as well, it could just come out of here then, couldn't it? Yeah, because D's also in here. So D, F, G is also from J. So that's already, 3 of them already go into here. So we know that we can do that. I would also have to go into here. Or maybe for then D, F, G to come out. And also, where is G, F, D, E, and I? So what we could have is E and I can now come together, because can you see they're both like this? So I'm going to scribble this out. And we're going to have E and I come together. We know that D, F, and G, but what I'm going to do is I'm going to bring that out a bit. Let's say they come together here, yeah? This is where we have to keep rubbing out. Okay. So I is going to come to here. Sorry, I've put E, haven't I? That's I. This is E. And now what we could do is actually add in a dummy from here, because that actually includes D, F, and G. From this point, now we can have L. Now we know that L is not going anywhere. Yeah? And we know K isn't, nothing depends on K, so this must be the last point. We notice now that we have a J with nowhere else. If I have a J, what could I add to get to the last point? Because J can't just be on its own. So I'm going to add another dummy. Okay? So it is about trial and error and not being afraid of rubbing things out. If you're spending more than 5 minutes on this, I would try and time yourself. Just know that you are definitely going to get some method marks. Some are way easier to draw than others. Some are really easy to draw. Some are a little bit more difficult. Okay, so in the mark scheme, this isn't a unique solution. And what they've done is they've actually got rid of... So I've used J as a dummy that we don't actually have to use here. Because if you look at the way I've drawn it, and this is what's exciting. So that was HK. If you see, if I drew it like this, HK, this J here that I've drawn and added a dummy, I wouldn't actually need a dummy for. Now the good thing, okay, so there we go. So I've now got rid of another dummy. Okay, but you could see before it didn't look like I could get rid of it. So it looked like it was, you know, so it really does depend. The mark scheme shows one solution you could use. That isn't always, you know, the best. I think most of the time it is the best way, but it isn't always the best way. And you might have a slightly different one. As long as what they check is that what's coming out of a node is has the right dependencies. It's a very hard question to mark this when you're an examiner marking this, because there is not a unique solution. Okay, so on this where I had that extra dummy, I would have personally lost 1 mark.
So how many dummies at most?
I think there is no right or wrong. It depends on the CPA. There is no right or wrong at most dummies.
But doesn't it always say with the minimum number of dummies?
It doesn't. It might say It doesn't say it might say the minimum, and anything more than that, in this specific mark scheme, it says if they have extra dummies, they can't get the final A mark. Okay, it really does depend. Right, part B. State which activities cannot be critical, given that all critical paths for the network include activity H. So activity H is critical. This is critical from here to here. If that's critical, state which activities cannot be critical. So J is definitely not critical. Yeah? L, I and E. Because it could go C, could go from here to here, up to F, then up to H. Could go C here, then down to G and up through H. But I, E, L and J, we could never start here and get to them to go through H. And remember, a critical activity will form a critical path. So if we have a look, I, E, L and J, no matter which path we take, we will never be able to do one of those and then go through H. Or one of these do not come out of H. Okay? So the answer here would be E, I, L and J. Okay, bubble sort XY question, random one at the end. Right, so let's start from just after part C, then this is practically the whole of the question here. Okay, so we really need to read what's happening. So the 10 distinct numbers below are to be sorted into descending order. Okay, descending order means I want it to be from biggest to smallest, okay? Now, I know we all know that, but a lot of us just we need to make sure that when we're reading, we read it properly. A bubble sort, starting at the left-hand side end of the list, is to be used to obtain the sorted list. After the second complete pass, this is the list. Okay, so they've done a pass twice, and this is what's happened. So what we're going to do is we're going to do a pass once. Okay, we need to find what was in the middle from here to here. Yeah? Yeah. To then help us out. So let's start. So 20 to 24, that changes. Yeah? Now 20 to 17?
No.
No. So that becomes 20. Now we do 17, 26. 17 and 8.
No.
8 and 15. 8 and X.
I don't know.
No, but what happens? We don't know, but if we look below, X has been swapped, hasn't it? Okay, so we're now on 8 and X. So that must be an 8 here. And then X must be smaller than X.
Then Y?
Sorry, X must be smaller than 8 for a minute, don't we? Then we have X and Y. And X swaps again, because in a minute we're going to see... Wait, what? Stop, I've confused myself.
Is X is greater than 8?
Yes, X is greater than 8. Yeah, X is greater than 8. Done that the wrong way around. Okay, right. So now, X and Y... Well, we don't know actually, do we?
No, we do.
No, isn't X smaller than
Y
Y?
is greater than X.
Because in the second pass.
Yeah, I know it's greater than. Okay, so let's say that Y... So let's swap these round.
Yeah.
Y and X. We know that X is less than 15, don't we? So X must have then swapped with 19. We're not sure about the 12.
We are.
We're not.
Just look at the second.
Oh, because of the second list?
Yeah.
Yes. So what does that mean about X?
The X is X is less than, it's greater than 8, but less than 12.
Okay, perfect. Happy with that?
Yeah.
Yeah?
That's the mark I got.
Right. So we would have got a mark there just by figuring that out. Right, now let's have a look at the Y. Let's do the Y. So 24 to 20 stays the same. 20 to 26 we swap, yeah? Then we have 20, then we have 20 and 17, 17 and 15, 8 and Y. Okay. So that means Y is also greater than 8. Yeah, if we swapped it, Y is definitely bigger than 8, isn't it? Okay. But Y is not only greater than 8, Y was also greater than X, wasn't it?
Yeah.
Because earlier we definitely swapped them. Okay. So Y is greater than X. That's all we know, I think.
No, I wrote the answer.
Okay, now just checked the mark scheme. I think they allow you 1 mark though if you do get Y is greater than 8, because we've just established that. But then we also established earlier that Y is greater than X because we swapped it in the one before, and that's all the information we know. Okay, state the number of times the vertex will appear. So we can see this is down here. Okay, so this is after we've done the question. And now we're at C. So assuming that this is correct, okay, assuming this is correct, from C currently we have 1, 2, 3, 4, 5, 6, and then we've added 2. 1, 2. So we have a total of 8 now. Okay, so assuming this part of the question is right, imagine this is 8, this is correct. How many times will, it says, state the number of times vertex C will appear. So imagine we're coming in and out, in and out. Now a handy trick that I've come up with is whatever the number is, divided by 2, and if it's a decimal, round up. Okay, if it's not, the answer's 4. But why does this work? Okay, this is just a handy trick, but you need to know why. First of all, okay, so imagine we're going to do 2 scenarios. There's only 2 scenarios, possible scenarios. Number 1, we start at C, is one scenario, yeah?
Yeah.
So if we started at C, we go out, that's 1. Okay, so this is how it would start. When we were writing our list, it'd be like C, we'd go out, blah, 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 blah. Okay, we'd come back in. So we'd visit C once. Then out. Then in. Then out. Then in. Then out. Then in. How many pairs of out and ins do we have? 4. So that means it's been?
4 times.
Yeah,
So
we visited 4 times.
Leave and come back until 1 visit.
Yeah. Or the other one, maybe we start somewhere else. Okay, maybe we start somewhere else. Okay, so you either start at C or you start elsewhere.
That's how you identify if you're right or wrong.
Okay, if you start at C or start elsewhere, let's say we started elsewhere. Well, we wouldn't start at C, so we wouldn't come out. We'd come into C.
Yeah.
In, out, in, out, in, out. You ever heard of the hokey pokey?
Yeah.
In and out. That's what I'm thinking. In, out, shake it all about. Okay. Absolutely, that is the song. So that is what it's asking for. Okay, the next part of the question says about D. Okay, so again, another handy little trick for D. Let's have a look at how many there is now. So for D, we've now got 1, 2, 3, 4, 5. Now this is assuming that this is done correctly, okay? Imagine it's 5. 5 divided by 2 is 2.5. We're going to round up 3. Okay, and that is because, right, imagine we're writing our list. We're going from A, B, C, D, and then from D we go to E, we come back to D. Is because when we come in and out, we only write D once.
Yeah.
Okay, so we have in, out. That is a D once, isn't it? That's saying we get to E. Okay, so imagine we came from G, we go into D. So that's G, D. We go out of D to F. Even though there's 2 nodes, we only write it once. So we visited it once. Okay, then imagine we do something, dot, 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 dot. We're at C and we come into D. So it goes C, D. And then we go out to B. Again, we've only written it once again. But then, because we're making a tour of all of them, we will have to come back at one time. So then we come back here. So you can see we've got 1 pair, 2 pairs, and half a pair. So it has to be 3 times. Okay? So I hope that helps. And that's how we do C and D. I'm not even sure if this is in the syllabus anymore, but with some of the past papers we have been using, it says find the maximum number of iterations needed for a list of 72 names down here. It's worth 2 marks. It's really simple. Okay? Because the whole point of binary search is we're always adding 2 numbers, aren't we? And essentially finding the mean. Yeah? This is basically we're doing base 2. So the formula is always log to the base 2 of the amount that we're searching. So in this case, it's the names. Okay, and even if the answer was 9.2, we've got to do 9 in a bit iterations, so that actually means 10. If the answer was 9.8, still 10. If the answer was 5.1, 6. Yeah, you know, it's one of those rounding ups. You know, if I said to you, go buy me 5.4 bags of flour, you're going to have to buy me 6 bags of flour, and we're going to have some left over, aren't we? Okay, so it's always log to the base 2 of the amount we have in the list. In this case, it's, you know, the names. Sometimes it might be types of cars. I don't know. Okay, it's not always names. Okay, and then you'll be able to find that. Or maybe they will say to you, now I haven't seen this, but maybe they'll say, for a list of X names, we only needed 12 iterations. How many names roughly? You just work backwards. We all know how to do logs. Yeah? And if you don't, please go back to pure 2. Brilliant. Okay, so scheduling without having a cascade chart or Gantt chart first. Some of us finding this difficult. So first of all, complete the precedence table. Then, when you complete diagram 1, and you'll have your critical activities. And then it says calculate the maximum number of hours. No, don't worry about that. Calculate the lower bound. Now this lower bound is going to help us. What is the lower bound? 4. Okay, if the lower bound is 4, this is going to give us a clue that when we're scheduling, okay, so when we're scheduling, we only want 4 rows. If we can do it in 4 rows, we know that we're right. Now with scheduling, it's like a puzzle, just putting together the pieces, okay? So, providing that what you did earlier was right, okay, let's have a look at your completed, okay, chart. So, first of all, we try and start in alphabetical order, okay? So then okay, so first step, it's already done some of the work for us. So I'm going to start cancelling what we've got. So we've done A, we've done B, we've done C. Okay, A, B, C, G, J, N. Okay, that must be our critical path, yeah? So now, what I now need to try and do is obviously using a ruler. Okay, I just need to schedule this. Now, it is a case of best fit works. So I always try and go in alphabetical order. So A, B, C, the next one is D. So D can start at 5, it's 8 long. Does any of these finish at 5? A does. So I'm going to put it there because I want to minimise any wasted space. So it's 8 long. 1, 2, 3, 4, 5, 6, 7, 8. There we go. D. Okay, I'm going to cross that off. A, B, C, D, E. E, the earliest time it can start E is at 10, isn't it? Slightly annoying because that means we are going to have some wasted space. Because if E went here, it's 10 and it's 4 long. 1, 2, 3, 4. Okay, now we might have to rub this out. And it's a shame that it's worth so many marks. So E, the next one is F can start at 3 and finish at 23. Okay? So if F can start at 3, but it is dependent on B being done, but it can start at start at 10 and finish at 23. Well, I'm just going to slot it in here. It's 3. It's done after B. It doesn't matter that it's not on the same line as B, because that's a different worker.
You said it starts at 10, right?
Yeah, it has to start at 10, finish at 23. The thing is, though, it's only 3 long, so it can start anywhere between that. You know, when we do a cascade, this would be 10, this would be 3, so this would be 13, and then we'd have this 23 here, wouldn't we? This would be up to 23. So what this is saying, what we have to imagine, is that actually, here is my box. Okay, I can fit that box anywhere in then. So what I'm doing here is I'm doing it in my head and thinking, right, it can't start any earlier than 10. It has to be completed after B and C, so I have to check that A, B and C are behind, but I don't actually have to check that because that's the whole point of it having a 10 here, because that will 100% make sure. Okay, and then I can move this anywhere in between here. As long as the duration is 3 and it's completed by 23, I could put it here, 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 or here. Okay, so A, B, C, D, E, F, done. G's done. H has to start at 10. It's 14 long. To be honest, I know I'm going to have 4 rows because we worked out the minimum was 4. So what they're also looking for in the mark scheme is that I have 4. I will probably, because it's such a long one, put H. It has to start at 10 and finish at 27? 24?
32. No, at the bottom is 32.
I'm really confused, but let's just do 10 let's just start at 10. Okay. And we're going to go 20. I can't even see. There's H. Okay. So I've just put in H there because I don't want to move it anywhere else. Because A, I can't read what's going on here. A, B, C, D, E, F, G, H, I. I, again, I have no idea what that says. 14. Okay, it has to start at 14. It can finish at 25. Yeah? It's 11 long.
So 14. It can
So there is no... So after E, perfect. So plus 11, we're going to finish at 25. It's I. After I, J, we did it. Then K, 15. Now can you see this can finish at 37? So I can put this anywhere. And do you know what? I'm just going to slot it in the first available one. K, 1, 2, 3. I have no idea. That's 1, 2, 3, 4, 5. Here we go. I think your handwriting needs to change. Right. After K, A, B, C, D, E, F, G, H, I, J, K, L. What time is this?
24, I think.
24?
This is just the 4.
Okay, I'm probably gonna put L after H anyway. Okay, I'm just gonna add 10 here to 34. Okay, done. L.
Misty, did you mean to write L?
Oh, honestly, it's because the handwriting is so bad. It's making me do that. No, I'm joking. Oh no.
Yeah, I'm not.
I think I'm just gonna skip it, yeah?
Yeah, it's only 3 marks. You don't have to skip it.
Only draw the first one.
Yeah, if you draw the critical... Oh, what? I just want to write. If you draw the critical path, you're definitely going to get 1 mark. This is something you could skip till the end if you want to, because it does take a bit of time. We're 7 minutes deep into this question for 3 marks. L. What did I do? L. Then it's M, isn't it? I would probably put M after I, and then just get straight to 35. Is that there? Yeah. Okay, and then M, then what? N, done. Then P, so I'd do 23 plus 11.
So you put the next to K.
P here. So 23 plus 11 is in fact, yeah, can you see that's wasted space now? Just make sure that you know it's wasted space. That's P. Q, 37 to 42. Okay. And again, we have wasted space. And then we have R, is that 37? I hope so.
No, it's at 34.
What?
That's 34 minutes.
Well, that's okay. So we didn't have to waste that space with Q. It's just I can't read. Oh my. I know, honestly. Right, so then if it can start at 34, it's only 5 long. Is it? Was it 5?
Yeah. Miss, that's not my handwriting.
Whose handwriting is this?
That's the printed thing.
34 and 7 long.
No, the early event is 42.
This is 7.
Oh, yeah. Miss, I thought you were talking about that.
Okay, and this is Q. And then lastly, we have R. Is this 34?
Yeah.
Right. So, yeah, it can start on any one of these, and it's 5 long. 1, 2, 3, 4, 5. There we go, R. Now, please make sure that your handwriting is legible. Okay, and then it's going to look something like this. But as you can see, you know, we're 9 minutes in. It probably, okay, let's be realistic. Take off 2 minutes because I didn't have a clue what was written. Okay. As you can see, it's like a jigsaw puzzle. You've just got to fit it in. What is really fantastic is that they asked you the lower bound earlier, so you know if you've gone over 4 rows, you've gone wrong, just leave it, abandon ship, carry on with the rest. Okay? Okay, so wordy questions. Now again, we're assuming everything from question 2 downwards is correct. Oh, that's got nothing to do with the question, has it? Mm-hmm. Okay, question 3. Explain why it is impossible to draw a graph with exactly 4 vertices of orders 1, 2, 3, 3. Okay. There are only a few ways we could draw graphs. If we look at the order, we have 3 odd. Remember, we can only have an even pair of odd vertices. Okay, this isn't a graph. This isn't going to be a graph at all. If you tried to draw it, you wouldn't. Okay, remember Eulerian, they're all even. Semi-Eulerian, yeah? We have sometimes we have like 1 pair of odd, 2 pairs of odds, but that kind of thing.
Yeah.
Okay, so you're happy with that one?
Yeah.
Brilliant. Okay, next one. A simple graph is one in which any 2 vertices are directly connected by at most 1 arc and no vertex is directly connected to itself. A connected graph, they're just giving us some definitions. Explain why there is no simply connected graph with exactly 4 vertices of order 1, 1, 2, and 4. So 1, 1, 2, and 4. Yeah? First of all, so this can only have 1 coming out of it and 1 coming out of it. So that is then not going to be connected to the ones with 2 or 4. Because the 2 is going to have, so 1 like that, 1 like that. Then let's say it comes out like this. And then this is going to need to have a loop. But we can also see they're completely not connected. So explain why there's no simply connected graph. Well, first of all, if one of them's got a node of order 4, it's going to cause a loop. Okay? Also, when you're reading this though, okay, you can see where it says, and no vertex is directly connected to itself. With an order 4, the vertex is going to be directly connected to itself. So that's one. The other thing, it says no simply connected. So that's a simple graph, but this is asking simply connected. So even though you put that, you might not get the 1 mark. Because it says here, a simply connected graph is one that's both simple and connected. Okay? The key word here being connected. Yeah? They can't be connected at all.
So how would I write that?
Or they could, actually, because if we put 1 and 2 here, that could come to here, yeah? That could be 1, that could be 4. So there's your 2, there's your 1. So we can now have it as a connected graph. Okay, it depends how you draw it. But the main reason is because vertex 4, it's not going to be simple.
Yeah.
Like simply, yeah? So it does depend how you draw it, but make sure you won't get the mark if you just say because it's not connected if you've drawn it this way. Yeah? So I would say, if I was to write this as a sentence, I would say the vertex with order 4 or order 2 would have to be connected to itself. Because here we've got, this is correct, but we could also do this. 1, 1, 2, so that could go there, that could go there, that could go there. Yeah? This needs to be 4 now. That could go there. 1, 2, 3, 4. No, that doesn't work, does it? No, I think it just has to be vertex 4, not all 2. Yeah? Perfect. Then, okay, connected graph has 4 vertices, A, B, C, D, in which A, B, and C have order 2, and D has order 4. How do you know the graph is Eulerian?
They're all even.
Yeah, they're all even. Perfect. And then it says, draw an example of such a graph and write down an Eulerian trail for your graph. Just means that you start and finish at the same point. An Eulerian trail is starting and finishing at the same point. So if you chose to start and finish at D, for example. Okay? So a graph has 3 vertices, A, B, and C, of orders A, B, and C respectively. What restrictions on the values of A, B, and C follow from the graph? If it's simple, okay, going back to here, any 2 vertices are directly connected by, at most, 1 arc, and no vertex is directly connected to itself. So they all going to have to be order 2, yeah? You need to write the word order 2, not equal to.
Oh, okay.
Yeah?
All right.
So be explicit here.
Because like in the question it says with orders A, B, and C, and like.
Yeah, so you could even write orders, the order of A, B, and C. Like order of A has to be 2, order of B has to be.
Yeah.
Just make it a bit more explicit.
Okay.
And then connected, every vertex is joined directly or indirectly to every other vertex. That's fine. And then for semi-Eulerian, so here you've put A, B could be 3, and C could be 2, but actually B and C could be 3, and A could be 2.
True.
So the restrictions for this one is all the vertices will have to be even. Okay? Remember it's asking for the restrictions, so it doesn't have to be 2, they could all be 4.
But how can you have?
Oh no, they can't be 4
Because
for
in a
simple,
yeah.
but connected could all be 4.
Yes.
So the restrictions here for simple, it has to all be 2.
Yes.
Restrictions for
It
connected,
could be an even.
they all have to be even.
Yeah.
And then for semi-Eulerian, you need 1 pair of odd vertices,
Yeah.
and the other has to, and then the other has to be 2. So you could say 1 pair of odd vertices, and the other one
Has to be even.
has to be even, won't it? Do you understand?
Yes,
So you still, I don't know if you'd get the full 3 marks here.
Yeah, it's because, yeah.
You have to physically explain it because it says what are the restrictions. The restrictions for simple, it has to be, everyone has to be order 2.
Right, yeah.
The restrictions for connected, they all have to be in even order. The restrictions for semi-Eulerian, we need 1 pair of odd nodes. For this question, because we've only got 3, we can't have 4 pairs of odd nodes because we only have 3 pairs, 3 nodes, so we have to have 1 pair, exactly 1 pair, yeah? Oh. Okay, so this is called linear programming common sense because we need common sense for this type of question. So, what we've done is we've done the whole question. Everything's correct so far. We're on part E, and part E says, given the expected total profit in pounds, find the maximum profit, blah, blah, blah. Now, before that, you would have done all the work and you would have found the exact coordinates of V. Okay, so as we can see here, classic mistake. We found the coordinates 160 over 9 and, wait, is this 60x plus 36y? Yeah. And then this would be 80 over 9. So these were the coordinates of the optimal point. Okay. First rule of common sense. If we look at the context of the question is talking about books specifically, okay? The factory is not going to make 160 over 9 of book A. That's ridiculous. So what do? We find the decimal of that, don't we? Okay? So when we find the decimal of that, what do we get?
So 160 over 9 is 17.7.
17.7.
And 80 over 9 is 8.8.
And 80 over 9 is 8.8. Okay, perfect. So, do we round up or down is now the question. And the answer is it completely depends on the graph. Okay? So we have a look at 17.7. Where is 17.7 on the graph? Well, we know this is 17.7. The region is anything less than 17.7. So the nearest integer is in fact 17. So for that one, we would round down. Again, common sense, everyone, just really common sense. Then we have 8.8. Now, if I have a look for my optimal region, 8.8 is roughly here. In our optimal region, if I go across, I can slightly go up from 8.8, okay? Because 17.9, what I would do is I would double check, because 17.9 is quite hard to tell from the graph, isn't it, if we round 8 up or down. Because even 8, if I round 8 down, this is 17.8, is that correct? Yeah, this is 17.8. This coordinate, that is not in our optimal region, is it? Yeah? Okay. So, sorry, that's not even 17. What is this? 18. Where's 17 now? Here. This is 17.8. This is not in our optimal region. Oh, I did not want to do that. 17.8 is not in our optimal region. Okay, and that's here. But 17.9, which is up here, is in the optimal region. We have to go back to this. When in doubt, substitute your values in and work it out. Thank you. So make sure we are using common sense here. This is why it's called linear programming common sense. So for this one, we round down. Whenever we round up or down, normally, sorry, we round up on that one, don't we? Whenever we round up or down, normally, when I say, right, if you need 4.2 bags of flour, well, how much are you going to buy me? 5. That doesn't always mean the rule is round up. I'm giving you an example about flour to make you realise it's common sense. So always refer back to the graph. or put it into some of the inequalities and see if it holds true. You can always put 79 back into your original inequalities. If you put 18 and 8 in, is it greater than, is it less than? Back into your restricts and see if it holds. Okay? Do that. Another common sense question. Now again, I know what we're like in this class. I don't even know if this question is right or not. I just know what mistake you've done straight away. Okay? So, we've got all of this, right? You've done all this, you've worked it out. You've probably simplified everything, haven't you? Mm-hmm. Yeah? So, you know, I can't wait to see your face in a minute. So you know that the cost of each training day is 400, oh, let's not use that colour, it's not very nice. Okay, so we've got 400x plus 550y plus 750z. Okay, but you've got to use the ruler method, the vertex method, whatever, to draw this on the graph. So what have we all been doing? Of course, probably going to divide everything by 10, aren't we? Minimum. Okay, I might even go one step further, divide it all by 100. So 4x plus 5.5y plus 7.5z. Now, obviously, earlier in the question, we got rid of the z, okay, and this turned into something else. And what you ended up with is when you rearranged and everything, you got 4x plus 10z, okay? And this is what it became.
10y.
Sorry, exactly what I meant, 10y. And this is what it became, and this helped us, because if we have a look at the graph, you know, it goes up to 16. So really, we can't be working with the hundreds, can we? Because our heads don't compute like that. And that's fine to do that then. But when we're talking, it then says, part E, what is the total cost? Well, when we're talking cost, don't forget, we've got to go back to how much this costs in pounds. Okay, you divided by 100 earlier, times back by 100 now. Can't just change the value of money. You've now, if you substitute 4 in here, like you have, you're now saying the course costs £4. When it doesn't. How much does the course cost? Clearly says in the question, £400.
Because he should have divided C by 100 on the other side as well.
Yeah, so you should have said here, either you could have said C is 100, C over 100 equals this, for you to know that that's the right way. Or just use your common sense and know that, of course, if yours is costing £95, that's ridiculous. None of the courses are cheaper than 100. Doesn't make any sense, does it? Okay, next up, 40 over 3 of a course. I mean, we just came to this common sense question. We need a whole number of courses. The school aren't paying for 2.5 people to go on a course. We can't do it. There is no 2.5 middle leaders, okay? People are whole people. Treat them like it. Don't leave them hanging, divided by 3, okay? So using common sense, it's fine to do this, to draw the graph to help you. But please know that when it comes to maximisation of profit or minimisation, and we're looking at cost, when we are working with money, we do not simplify money when we are working the cost. Okay? If you go to the mall this weekend and on your receipt it costs you 400 dirhams and on another receipt it was 500 dirhams, are you going to divide both by 100 to make it simpler and go home and say yeah, I spent 9 dirham? Of course not. You spent 900. The value doesn't change. In your head you've simplified it because you've done 4 plus 5, but we can't take away the value. So, common sense. Think about the context of the question, yeah? Well done, guys. Sorry, I didn't finish with this. Another mistake. Earlier, we were told that y equals something z, or x, or whatever, and we substitute that back in. When we come to the cost, I know we redid this cost, but the cost, our optimization function did not change. It's still going to be 400x plus 550y plus 750z, and you will need to substitute in your value of z into that formula that you had earlier, whatever it was, you still should have free values. We don't just lose the senior leaders or whatever it is that we're losing in this question. They can't be gone. We still have free courses, so you still should have free things. Yeah? Please always go back to the question. Well done.